Good evening, everyone. I am Riya Tapwal. I am doing my PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. And today we are going to discuss the topic of week 8, and after that we will discuss the assignment question of same week. So, yesterday we were discussing about about SDN, that how the integration of SDN will be beneficial to IoT. And now we will continue this topic, but before that today we will discuss that how the integration of SDN with your mobile network will be beneficial. But before that we will discuss the problems that are existing in your traditional mobile network. So first of all, your traditional mobile networks are difficult to scale because these are static over provision network and are inflexible to manage the mobile traffic with high demand. Second is the traditional networks are difficult to manage. Many times it leads to misconfiguration in case of your traditional mobile network. The next challenge is that these are inflexible. They require too much time in order to introduce new service, as the hardware architecture in case of your traditional mobile network is flexible. Then also your traditional mobile networks are cost expensive. Now in order to resolve this problem, we can integrate SDN with your traditional mobile network, and the integration of SDN with your traditional mobile network helps in removing those challenges, because in case of your SDN there is one central controller which is going to manage the complete mobile network. Now SDN for mobile network. So first of all, flow table paradigm of SDN in case of your mobile network. So it should be well suited for end-to-end communication over multiple technologies such as your Wi-Fi, 3G, 4G, etc. It should be the logically centralized control should be there, particularly useful for efficient base station coordination for addressing the inter-cell interference, because in case of your mobile network there are chances that the mobile node is getting signal from two different cells, due to which interference can occur. So SDN will be helpful in removing those interferences which is coming from different cells. So with the help of your SDN controller, you can manage that from which cell exactly your mobile node will get signal. After that, the path management. So data can be routed based on the service requirement without depending on the core routing policy in case of your mobile network. And after that, network virtualization. Since in case of your SDN, network virtualization is there, so with the help of network virtualization, it abstracts the physical resources from the network services, which helps in providing the seamless connectivity and service differentiation among the user. Now the key benefits of integrating SDN with mobile networking. So first one is centralized control of devices manufactured by multiple vendors will be there if you integrate SDN with mobile networking. Second is higher rate of integration of new services. Third one is abstracted network control and management. Now the challenges. So the journal OpenFlow does not support wireless network, so we have to introduce some protocol which will support your wireless network. The modified the modified version of OpenFlow is required, which can support your wireless network. Typically the users are mobile in nature, due to which the network is dynamic. So in order to manage a dynamic network, it is difficult, right? So this is also one of the challenge. Then the frequent changes in rule placement is also required. This is because your network is dynamic, the users are moving continuously, so due to which the rule placements, there will be frequent changes in the rule placements, so we need to make those changes very frequently, right? So that is also required in case of your wireless network. Then the presence of heterogeneous devices in the network is there. And then last challenge is how to support such heterogeneous devices in a single platform. So heterogeneity is also one of the biggest challenge in order to integrate your SDN with your wireless network. Now the approaches that can be adopted in order to integrate your SDN with the wireless networks are we will discuss about 3 approaches. First one is your ODIN, second is your OBFlow, third is your MobiFlow. Basically these are the approaches or methods provided by various researchers. So you can if you want to know about these approaches in detail, you can read the research papers. I'll give the brief overview of all the 3 approaches to you. So first one is your ODIN. So in case of your ODIN, an agent is placed at the access points to communicate with the controller. So basically in case of your SDN, what happened is your hardware is separated out from your application layer as well as from your controller layer. So basically whenever you want to integrate SDN with mobile network, you will place an agent at the access points. So these agents will help the access points in order to communicate with your controller. So you will place first one will be your ODIN agent and second one will be your ODIN master. So ODIN agent is placed at the physical devices and ODIN master is placed at the controller. So the physical devices will communicate with the controller with the help of these ODIN agent and ODIN master. So physical device firstly communicate with ODIN agent, and then the ODIN agent will communicate with the ODIN master, and further ODIN master will communicate with your controller, and in this way the communication will take place. The second method is your UBFlow. So UBFlow is responsible for mobility management of your SDIoT, that is software defined IoT. It provides scalable control of your APs and provide fault tolerance. It is also responsible for the flow scheduling of your data. So in order to schedule the flow, it adopts network partitioning. First of all, the network is divided into various sub networks, and then after that network matching is performed. Network matching means for each sub network one controller is matched, and that controller is responsible for managing that particular sub network, and after that load balancing is done in between these sub networks. Then next is MobiFlow. So the MobiFlow is for proactive rule placement depending on users movement in the network. And the approach is it predicts the location of end users at t+1 time while the user at t time. So basically MobiFlow is going to predict the next location of the user, and by predicting the next location of the user, it is going to place the flow rules into your switches. So basically with the help of these locations the flow rules are placed, and on the basis of those flow rules the data is routed to the destination node. So for location prediction, this method adopted order K Markov predictor, and for rule placement a linear programming was used in MobiFlow. Now the rule placement at backbone network. So the existing rule placement schemes for wired network can be used in this case also. Load balancing is an important issue due to the dynamic nature of your IoT network. So whenever you are going to integrate SDN with the wireless network, you should consider the load balancing factor also. And the next one is your dynamic resource allocation can also be integrated. Now data centric networking. So in data centric networking, two types of flows are considered. First one is your mice flow. So in case of mice flow means a small amount of in case of your mice flow, small amount of data is flowed from your source to your destination. So wildcard rules can be placed in order to deal with your mice flows. However, in case of your elephant flow, large amount of data or large chunks of data are sent from your source to destination. So in this case exact match rules are used. So we classify the flows before inserting the flow rules at the switches, and depending upon the classification different kinds of rules are used. Now the anomaly detection in IoT network. So It monitors the network through OpenFlow to detect any anomaly in the network. This can be done by monitoring each flow in the network. We can also collect the port statistics of the switches, and if there is an anomaly in the network, it may generate large number of packets in the network, and that can be detected by monitoring the flows. Now experimenting with the wireless network. So Mininet Wi-Fi is there. It is software that can be used to deploy a network where SDN is integrated with your wireless network. It supports both wired and wireless network. So for wired, Ethernet protocol is used in this case, and for wireless, Wi-Fi is used. The second one is ONOS. Here it can be used in order to place the controllers whenever you are integrating SDN with your wireless network. Now after SDN, the next topic that we will discuss is cloud computing. So cloud computing is a model for enabling convenient on-demand network access to shared pool of configurable computing resources. So computing resources may be your network infrastructure, server, storage, application, etc. So this is the definition which is given by NIST. So now we will see the evolution of your cloud computing. So first of all, the cluster computing came into the picture. So in case of your cluster computing, various homogeneous computing nodes works together in order to perform a particular task. So these homogeneous nodes are connected to each other either in loose manner or in tightly manner, and all those computers work together in order to perform a particular task. Now the second one is your grid computing. After cluster computing, the grid computing came into picture. So in case of your grid computing, heterogeneous computing nodes. So basically in cluster computing, homogeneous computing nodes work together. However, in case of your grid computing, heterogeneous nodes which are distributed over a network, they comes together and perform different tasks. Okay, then the third one is your utility computer. So in case of your utility computing, packaged resources are available for computing and storage. And after utility computing, your cloud computing comes into picture, where it is a shared pool of configurable computing resources. So various resources are available there. So based on the demand of the user can use the resources from that shared pool. So basically logically it is it can be seen that there is a large pool of resources where resources are there. However, in actual, these resources are distributed over various locations. It's not like that there is a centralized pool of resources. However, logically it can be seen that the pool of resources is centralized, but in actual it's not centralized. Now the evolution of your cloud computing. So from this figure it can be seen that in 1950 time shared mainframe computers came into picture. After that, in 1969 ARPANET came into picture. Then in 1970 virtual machines by IBM were introduced. Then in 1990 expansion of internet and inceptions of VPNs, that is your virtual private networks, come into picture. Then in 1996 and 1997 cloud computing came into picture. Right, after that in 1999 salesforce.com came into picture. Then in 2002 Amazon Web Services, 2006 Amazon EC2, and then in 2008 Google App Engine and Microsoft Azure were introduced. So this cloud computing, it can be envisioned as a step on from utility computing, because initially utility computing was there, so some changes were made in that, and it is the evolution of that utility computing. So it provides high level generalization of computation and storage model. It can be rapidly allocated and released with low management effort. It has some essential characteristics: service model, deployed model, which we will discuss later. It provides on-demand services that can be accessed from any place and any time. So on-demand services means, so whenever a user required any kind of service or any kind of resources, it will place demand from any place given that network connectivity should be there, so at any time 4/7 these services are available. So on the demand of user, the services are provided to him or her. Now the business advantages of cloud computing. So first advantage is nearly zero cost for upfront infrastructure investment, because in case of your cloud computing, various resources are available and user can access those resources on demand. So basically the users who wants to perform some task, he or she doesn't have to invest on the infrastructure. So the cost of infrastructure is nearly zero, because if you are for example, you need to perform some computing on the server, right? So if you are going to purchase the server, it will cost you around lakhs of money. But however, if you use cloud computing, then the price or amount of money you required in order to access the service is very less as compared to the cost of that particular infrastructure which you are going to purchase. So the cost is nearly zero as compared to whenever you are going to purchase the infrastructure. Second is real time infrastructure availability. So whenever you want to access the infrastructure, it will be available at that time. So real time availability is there. Third one is more efficient resource utilization. So more efficient resource utilization means whenever you want to use the resource, you can access that, and whenever your work is done, you can release that resource. So efficient utilization of resources is there. Then usage based costing. So the amount of resources you are going to use, you only have to pay for that amount of resources only. So usage based costing is there. Then reduce time to market. Now if you are going to purchase your own infrastructure, then it will waste your time also. However, in case of your cloud computing, this time is reduced. Now the general characteristics of your cloud computing. So first one is improved agility in resource provisioning. Second is ubiquitous. So basically the resources can be accessed from anywhere or anytime. So it is independent of device or location from which you are accessing the resources. Then the third one is your multi-tenancy. So sharing of resources and cost across a large pool of users is there in case of your cloud computing. Then dynamic load balancing is there. Next characteristics is highly reliable and scalable. So your cloud computing is highly reliable as well as scalable, because you can based on the demand of the user, the amount of resources can be increased or decreased. Then low cost and low maintenance. And last characteristics is improved security and access control. Now this is the architecture which is given by NIST. So this is NIST visual model of your cloud computing, where it has provided the essential characteristics, service model and deployment model. So the essential characteristics according to your NIST visual model are broad network access, rapid elasticity, measured services, on-demand self-service, resource pooling. We will discuss these each of these characteristics in detail after this figure. Then the service models. So the service models are characterized into three categories. First one is your software as a service. Second is your platform as a service. Then infrastructure as a service. And now the deployment models, that how you are going to deploy this cloud computing. So it can be either public, private, hybrid or community based. Now the characteristics. So first one is your broad network access. So what does this broad network access mean? So it means that the cloud resources should be available over the network, and they should support standard mechanism for information retrieval using the traditional interfaces. So it's not required that you need some advanced interfaces in order to use your or in order to access your resources. So these resources can be with the help of in case of your cloud computing, you can access these resources from anywhere, and you don't require any kind of special kind of interfaces in order to access these resources. Then the supported clients can be your heterogeneous thin or thick client. So you can access these network either from your thick or thin clients. Then next is your rapid elasticity. So cloud resource allocation should be rapid, elastic and automatic. Then dynamic allocation and release facility for scale out and scale in should be there. So depending upon the need of the user, you in case of cloud computing, you can either increase the number of resources which you required, or if the availability is less, you can decrease out the resources. So there is automatic scale out and scale in of resources there in cloud computing. Then the consumer should feel that there are infinite number of resources. So basically what I was telling is, in case of cloud computing, the user feels that there is one centralized pool of resources where we have infinite number of resources. So user will get this feel, but in actual the resources are finite and they are not present at a centralized location. However, they are distributed at different location of the world. Next is your facility for add and remove of quantity should be there. This I have already discussed that based on the demand of the user, there should be a facility to add or remove the quantity of the resources. Then next characteristic is on demand self service. So it provides server time and network storage to user automatically. This facility should be available as a self service. So it is not required, there is no need of intermediate person who is going to provide you these services. So whenever you require a particular service, you can directly on your demand, you can directly access the resources or particular service from cloud computing or with the help of cloud computing. Next is your resource pooling. So automatically pool the whole available resources. So whenever required, you can access the available resources which are present in the resource pool. At the same time, cloud computing can serve multiple end user using multi-tenant model, and resources should be allocated according to users demand. So it is not required that at one time only one user will be handled. So there are a large number of resources and multiple users can be handled at a particular time with the help of cloud computing, or one particular resource can be shared among multiple users at a single time. Then the last characteristic is measured service. So resources usage should be recorded and monitored. Then facility to dynamically control and optimize the resources usage is there, and this facility should be transparent between the service provider and consumer. Now the different components of cloud computing. There are various components of cloud computing. First one is your client or end user, second is your services, then applications, platform, storage, infrastructure. So clients are the end user which are going to access the resources. They can be either thin, thick or mobile. The second component is your services. So these are the products and solutions which are available and which can be accessed by the end users. For example, your identity mapping, search, all these are the services. Then next is your applications. So for example, your web apps, software as a service, these are the application. Then the platforms is a component of your cloud computing. Then storage, various storage is provided by your cloud computing database, are provided by your cloud computing database. Storage as a service is there. Then the infrastructure. Now the service models. So basically we have discussed that there are three service models which are there in your cloud computing. First one is software as a service, second is your platform as a service, and third is your infrastructure as a service. And these are the deployment models. First one is your public cloud, private cloud, hybrid cloud. We will discuss about these in detail later in later slides. And others are community cloud, distributed cloud, multi-cloud and inter-cloud. So basically hybrid cloud means the integration of both your public and private cloud. So first one is your public cloud. So public cloud means cloud setup for the use of any person or industry. So anyone in the network, anyone present in the network can access this public cloud. It is typically owned by an organization who offers the cloud service. For example, your Amazon Web Services, Google Compute Engine, Microsoft Azure. The advantages are it is easy to set up at low cost, as provider covers the hardware and application at bandwidth cost. Scalability to meet the needs, so scalability is there, and pay per use is there. So basically the amount of services you are going to use, or the amount of resources you are going to use, and the time for which you are going to use those services, you have to pay for that only. Next one is your private cloud. So in case of your private cloud, unlike your public cloud, only the members of a particular organization who owns this cloud can use this. So cloud setup function only for a single organization. It is typically managed by an organization itself or a third party also. So third party also can manage private cloud, and the members of a particular organizations can use this cloud. The advantages of private cloud is that total control over the system and data, because only a single party is going to manage this, so total control is there. Security concerns are less, because in case of your public cloud, anyone can access the data, or anyone can access the services, right? However, in case of your public cloud, the access is given to some members only who have authorization, right? So security concerns are less. The disadvantage of private cloud is that it needs regular maintenance. Now the hybrid cloud. So the cloud setup constructed by two or more unique cloud setup, that is your private, community or public. So integration of different kinds of cloud basically means your hybrid cloud, pulled together by standardized tools. It supports data and application portability and provides multiple deployment models. So now this table is showing the difference between your public cloud and private cloud. So in case of your public cloud, the virtualized resources are publicly shared. However, in case of your private cloud, these are privately shared by the members of an organization only. Then in case of your public cloud, the customers types are multiple, so it can be anyone from the network. And however, in case of your private cloud, these are limited, only the members of an organization can access. Then the connectivity in case of your public cloud is over the network. However, in case of your private cloud, it is over the network, or it can be private network also. Then the security in case of public cloud is less as compared to your private cloud. This I have already discussed that how the security is more in case of your private cloud. Now the other types of cloud. First one is your community cloud. So it is shared setup between several organizations having common concern. For example, cloud setup by your medical institutions. Different medical institutions are can use a same cloud, so it can be your community cloud. So for security, compliance or jurisdiction, cloud which is used by a particular several organization which have same concern is called your community cloud. It is managed internally or by the third party. It is similar to your private cloud. Then the distributed cloud. So distributed cloud means the collection of scattered set of computing devices in different locations, however connected to a single network. So it can be of two types. First one is your public resource computing and volunteer cloud. Then your multi-cloud. So multi-cloud or multiple cloud computing services offered by single heterogeneous architecture. It increases the fault tolerance and flexibility. Next one is your intercloud. So it is unified global cloud of clouds based on the networks, based on the internet. It support interoperability between cloud service providers. So intercloud basically means the superset of different clouds. So it is the cloud of clouds. Now the comparison of different deployment models. So basically, if you have dedicated access and it is on premise, then a private cloud can be used, and if it is off premise, then hosted private cloud can be used. And if you have shared access, then in case of your on premise, community cloud can be used, and in case of your off premise, public cloud can be used. Now the service models. So there are three types of service models. First one is your PaaS, that is your platform as a service. Second one is your software as a service, and third one is your infrastructure as a service. So in case of your platform as a service, particular platform is provided to the user in order to perform the application, right? In case of your infrastructure as service, infrastructure or different hardwares are provided to the users. And in case of your software as a service, complete softwares are provided, complete applications are provided to the end users. So infrastructure as a service, infrastructure as a service, which is also abbreviated as IaaS, contains the basic building blocks for cloud IT and typically provide access to networking features, computers and data storage space. So it provides on-demand delivery of computing infrastructure. It also provides server compute, machines, storage, network and operating system. So basically the infrastructure is provided in case of your infrastructure as a service. Now the working methodology. So the user rents the server, software and data center space or the network equipment to the end user. So on the basis of the time for which a particular infrastructure is used, the users are charged accordingly. So cloud service providers offers a resource management and outsource service on demand model. Now why infrastructure as a service is required? So for new businesses can operate without investing on computer hardware. So whenever you are going to set up new business, you need different infrastructures, right? So with the help of infrastructure as a service, you don't have to invest on purchasing different hardware. You can use infrastructure as a service and use the resources which are available in the resource pool. Second is scalable for rapidly growing businesses. Third is it is suitable for serving fluctuating computing demands. For example, your Flipkart, Amazon during festival sales. So there is a cloud computing is scalable basically, so it can handle the fluctuating computing demands. Then it is suitable for new business model trials, and it also helps in minimizing the capital expense. Now the characteristics of infrastructure as a service. So first one is your manageability and interoperability. So what does this manageability and interoperability mean? So clients have total control of the virtualized infrastructure resources. Pre-configured facility for allocation of virtualized resources is there. The virtualized resources are to be monitored for their running status. The usage and billing system records the use of infrastructure resources and accordingly circulate payments. The next is your availability and reliability. So the stored data can be retrieved at any time without failure. The clients should be able to access the computational resources without any failure. There is uninterrupted facility for computation and communication. The third characteristics is accessibility and portability. So there is a facility for clients to ease the various tasks, for example, control, manage and access infrastructure resources. To facilitate easy reallocation and duplication of allocated infrastructure resources, infrastructure as service can be used. The next is performance and optimization. So there is high utilization of physical resources among different clients. to enable high computing power with a large pool of physical resources using parallel processing is there. Then to optimize the deployment of physical resources by deploying dynamic configuration of virtual infrastructure resources also there. Now the categories of infrastructure as a service. So infrastructure as a service can be obtained as first one is your public cloud. So there is shared infrastructure resources available for self-service basis. Second one is your private cloud. Private infrastructure resources are there, and they can be accessed on the basis of access control. So the users who have the access for particular resources can only access these resources. Then third one is your hybrid cloud. So it is a blend of both public and private. Now the challenges and limitations of infrastructure as a service. So first is sometimes the regulatory approval does not allow outsourcing the storage and processing of sensitive data. Second one is network latency may degrade the level of expected performance. Third one is users may require automated decision making of job scheduling to available resources. Then seamless scaling of services independent of traffic variation is there. Developers have to focus on low level system details. Now the next one is your platform as a service. So platform as a service removes the need for organization to manage the underlying infrastructure, that is usually your hardware and operating system, and allow you to focus on the deployment and management of your applications. So this is the definition given by Amazon. Platform as a service provides the platform which allows developer to create applications which can be offered as service by internet. It simplifies the application development and deploy, providing the Cloudware feature. Platform as a service is an application middleware offered as a service to the developers. It provides abstraction and security for deployed applications. Platform as a service also facilitates development and managing applications without the complexity of maintaining the underlying infrastructure. It allows customers to rent virtualized servers and associated services. It also provides elastic scaling of users' deployed applications. Now the features of platform as a service. So first one is your operating system. Second is server side scripting environment. Then database management system is there. Server software is there. You can provide support to the end user. Storage is there. Network access tool for design and development is there. And then hosting of different applications is there in your platform as a service. Then platform as a service working model. So basically it allows user to create software applications using offered tools. Second is it provides pre-configured features that customers can subscribe. It supports available for managing the infrastructure and application for customers. In case of your platform as a service, the services are regularly updated with new features. Then the business advantages. It provides facility for accessing key middleware services without worrying about the underlying complexities of managing individual hardware and software element. There is an ease of access for the development and deployment tools. There is also a freedom from managing development and deployment tools individually. Now next one is your software as a service. So software as a service provides you with a completed product that is run and managed by service providers. In most cases, people referring to software as a service are referring to the end user application. So this is the definition which is given by Amazon. In case of software as a service is a simplified model of software delivery over network. Operation, maintenance and technical support is provided by the service provider in case of your software as a service. It typically offered by web browser working as a thin client. It supports fully pay as you go model. So basically whatever you will use, you have to pay for that. Remote access of software by internet where web browser act as a thin client. Then a facility for access and control of commercial software by internet is there. Then multi-tenant application delivery in one-to-many model is there. Now this is the this table is showing the difference between your traditional software and the software as a service. So in case of your traditional software, customer install, manage and maintain the software. However, in case of your software as a service, customer uses the particular software over the internet. So traditional software runs on individual organization on dedicated instantiation. However, in case of your software as a service, it runs on multiple customers simultaneously. Then in case of your traditional software, cross-platform support is required. However, in case of your software as a service, no concern for cross platform service support is there. Then next one is your less frequent version updates and purchased separately in case of your traditional software. However, in case of your software as a service, more frequent updates for enhanced user satisfaction should be there. Then in case of your traditional software, separate cost incurred for upgrades. However, in case of your software as a service, no separate cost should be there. Then next is your traditional software. It is vulnerable to software piracy. However, software as a service is less vulnerable to your software piracy. Now the architecture of your software as a service. So first one is your scalability. So in order to maximize the application concurrency, scalability should be there. To optimize the shared pool of resources such as threads and network connection should be there. Second one is your multi-tenancy. So important architectural shift from designing isolated single tenant application is there in case of your software as a service. It has the ability to accommodate users from multiple companies at the same time. So it also provides transparency to all the user and maximize the sharing of resources across the tenants while distinguishing users individual data. The next one is your configurability. So to facilitate the parallel allocation of single application on single server to several users. To customize the application of one customer will change the application for other customers as well. Then separate data space is there for different user in case of your software as a service. Now the limitations of your software as a service. So first one is your centralized control. So in case of your software as a service, there is a centralized control. So if that is one of the limitation. And then second one is your switching cost. Third one is your limited flexibility is there, and the fourth one is your data security and privacy. Now this is the this figure is showing the comparison of different service models. So basically in case of your in case of your traditional model, so all these things are maintained by users only. So application, data, runtime, middleware, operating system, virtualization, server, storage, networking, all these things are maintained or used by user only. However, in case of your infrastructure as a service, the service providers will provide the users with your virtualization, server, storage and networking. However, your user is going to maintain only application, data, runtime, middleware and operating system. In case of your platform as a service, the service provider will provide you the complete platform, for example your runtime, middleware, operating system, virtualization, server, storage, networking, all these things are provided by the service provider only. The user only have to use their own application and data. And in case of your software as a service, complete software, that is your application, data, runtime, middleware, operating system, virtualization, server, storage, networking, all these things are provided only by your service provider. Now service management and security. So it deals with the world of cloud computing and service management, ensuring optimal performance and efficiency in on-demand virtual environments. It aims to provide equal importance to desired outcome of customers. The management of services at no cost and risk is required in case of your cloud computing. Then the objectives are, in order to provide standard services, clear and complete description of services should be there, usage and usage monitoring and billing should be proper. So for the particular amount of time you are going to access the service, only for that amount of time the user should have to pay the bill. Next is high availability of networks and connectivity should be there. Then the ease of access, so the resources should be easily accessible to the end users. Portals for service selection should be there. Rapid fulfillment and decommissioning of resources should be there. Then service guarantees should be there. Secure computing and storage should be there in case of your cloud. Now the service level agreement. So service level agreement is a document which defines the non-functional requirements expected from the service providers. It basically provides a roadmap with clearly defined deliverables. It describes the quality, utility and warranty of services expected by the users from the service providers. Now the accounting and billing. So service accounting, so it aims to obtain resources usage information typically in the form of records. It depends upon the infrastructure and service monitoring, as usage information is obtained from the metric measurement. The next one is your billing. So the service provider calculates the billing information using your accounting records, resource prices and billing rules. So basically your service providers are going to use accounting records, resource prices and billing rules in order to calculate the bill of a particular service which is used by the user. Now comparing the scaling hardware for your traditional versus your cloud computing. Now in case of your traditional data center, heterogeneous hardwares are available, network computing is there and remote servers are there. However, in case these are available in on-premises. However, in case of your cloud computing, all the infrastructure is present at off-premises. Virtual hosting solution is there, and heterogeneous hardware, software and networks are available on the cloud. These are not available at the user's end. And then the major differences include resilience and elasticity. So basically in case of your cloud computing, resilience and elasticity is more as compared to your traditional data center. There is more flexibility and scalability, more automation, running cost is less, and there is more security in case of your cloud computing. Now managing the data in cloud. So first we will discuss the steps in evaluating the database manager. So it defines the type of application that will be served, like data asset protection, business intelligence and e-commerce. It determines how suitable these apps are for public and private cloud. The fact it also describes the factors affecting the easy development process. Then next is demand of cloud database management system. So it should be efficient, fault tolerant, adaptive to heterogeneity, and the operational comfort on encrypted data should be there, and it should be capable of interfacing with other products and solutions. Next one is database as a service. So basically your Microsoft Azure SQL database can be provided as a database as a service. Then next one is your Amazon Web Services, Dynamo database, relational database services are there. Then Google Cloud SQL is there, Google App Engine data store is there, ClearDB is there, database.com is there. So all these databases can be provided to the end user as your database as a service. Now cloud security. So the basic problem is user loses the control of information available on the public cloud. So basically there is a need of security. So in case of your cloud computing, because there are various security concerns that are present. So first one is your loss of data can be there, account seizing is the one of the major issue that can be there, service traffic hindrance can be there, then vulnerable APIs can be there. So the solution for this is there should be protection from theft, leakage and deletion by providing secure policies. Now the first one that we will discuss is infrastructure security. So infrastructure security means the security of cloud infrastructure must be implicitly assured in case of your cloud computing for both your public as well as your private cloud, and for all the services, that is your service as software as a service, platform as a service, and infrastructure as a service. Then building levels for viewing, evaluating and executing infrastructure security are network level security, host level security and application level security. So first of all we will discuss about network level security. So it should be in case of your public cloud, small change severely affects the network topology. Then there should be proper access control for using the resources, which can be achieved so we were discussing about network level security. So in case of your public cloud, small change severely affects the network topology, and there should be proper access control for using the resources, which can be achieved by confidentiality and integrity of data in transit to and from the cloud service provider. There should be availability of internet resources correctly to genuine user from the cloud service providers. Now next is your host level security. So host level we will discuss the host level security at a platform as a service and software as a service level. So it hides the host operating system from the end users, and the security responsibilities are transferred to the cloud service providers. Host security at infrastructure as a service level, the primary objective is to secure the allocated host. The example of the threat in case of host secure at infrastructure as a service level is blue pill attack and hypervisor. Then application level security. So both CSP and customers are responsible for security at your application level. Now the objective of now we will discuss about data security. So basically the objectives of data security is to ensure confidentiality, integrity and availability, and the solution available in order to provide these features are: first one is your identity management. So all the users who are going to access the resources, their identity should be managed properly, and the services should be given or the data should be given to the authorized user only. Encryption of data should be there, and access control should be there. Now the aspects of data security. So all the data, for example, the data in your transit, data at rest, data including multi-tenancy, data lineage, data remnants, and data provenance. So these are the various aspects of your data security. So all these different types of data should be secured. Now, identity and access management. So a branch of cloud security that allows the legitimate person to retrieve the legitimate resources at the legitimate time for the legitimate reason. The user identifies and access permissions are instigated, caught, and administrated and recorded by IAM in case. Then authentication, authorization, and evaluation of all the users are done according to the terms and conditions and the roles of the users. Now the features of IAM, that is your identity and access management. So it is a single access control interface. It increases security. Access control over resource level is provided by IAM. Then there is an improvement of operational efficiency. The organizations attain access control and operational security using IAM. It also results in the improvement of regulatory compliance management. Now the access control. So access control layers in cloud include cloud access, server access, service access, database access, virtual machine access, access to objects within the virtual machine, and the management of these layers depend upon the provider or the consumers based on the deployment model. Now the trust and reputation. So what do you mean by trust? So independent expectancy between two entities for any specific context at a given time is trust, and reputation is the belief of entities standing by the community. So these two concepts are needed by the customer in order to select the appropriate cloud provider. So different modes of trust establishment include accomplishment of your service level agreement. Second is your application of audit standards, measuring and ratings, and questionnaires for self-assessment. So basically, users also decide that which service provider to use on the basis of self-assessment, that which particular service provider is suitable for him or her. And then next is your risk assessment. So it is defined as the categorization of different assessment methodology. Formal versus informal procedures are there. Then qualitative and quantitative techniques are also there. Consequence versus cause analysis is there, and inductive versus deductive techniques are also there for doing your risk assessment. So basically different categories are there, and these are further 4 categories. First one is your formal informal, second quantitative qualitative, consequence and cause versus, and inductive and deductive. Now authentication in cloud computing. So user authentication. So user authentication process between new user and service provider. So service provider are going to authenticate the users who are going to access the services from that particular service provider. So during the authentication, the properties and safety of a process can be invaded by the attacker, causing the severe damages. So user authentication is done at your platform as a service layer, and the consequences threat to authentication process can lead to divulge of confidential data to fake user. Now the cloud simulations. So simulation tools provide reliable, scalable and repeatable environment for performance evaluation. The simulator facilitate pre-deployment test of services. As the demand of cloud computing is growing every day, the simulators and techniques are needed to be studied. So the cloud simulators allow customers to evaluate the services. It also allows testing at no cost, enable repeatable evaluation, control the environment. Pre-detection of issues affecting the performance can be done. Then the design of countermeasures can be done with the help of cloud simulators. Now the different cloud simulators that are available are Cloud Sim, Cloud Analyst, Green Cloud, Icon Cloud, Ground Sim, DC Sim. Now the questions, but before starting the question we will take a break of 2 to 3 minutes, and after that we will start the questions.
Ma'am,
Yes.
please can you share this PDF?
Yeah.
We can go through it.
I have already uploaded. Wait,
Why? Because
give me 2 minutes. I'll share the Google Drive link, and from there you can access. Now the questions. So first question is, which of the following is an issue relevant for communication in wireless sensor networks? Options are diffusion, interference, diffraction, inheritance. So the issue that is relevant for communication in wireless sensor networks. Options are diffusion, interference, diffraction, inheritance. Yeah, week 7 is also there in the folder. So I have shared the link of the folder with you. So all the PDFs from week 1 to week 8 is there in the same folder. Yeah. So correct option for this is interference. So basically in any wireless network that communicate using radio frequency, interference is major issue. So basically what happened in wireless networks is a particular mobile node or a node can get signals from different cells, due to which these signals may interfere with each other, right? So this is one of the major issue in case of your wireless sensor networks. Second question is, in cloud computing paradigm, the user does not have availability to on-demand services. Is this statement true or false? So I'm repeating the question again. In cloud computing paradigm, the user does not have availability to on-demand services. True or false? Anyone? So in case of your cloud computing, what happened is, whenever end user wants to access the services or resources, he can. So but the requirement is network availability should be there. So there is an availability of on-demand services in case of your cloud computing. So this statement is false. So cloud computing is built for providing dynamic on-demand services. Next question is, which among the following can be rented as a utility service by a client remotely in cloud computing? Options are hardware, software, memory and storage, all of these. Anyone? Which among the following can be rented as a utility service by a client remotely in cloud computing? Options are hardware, software, memory and storage, all of these. Anyone? So the correct option for this question is all of these, because in case of your cloud computing, the clients can access all these things, that is your hardware to software and infrastructure, on the basis of demand from the service providers. Next question is, that is your question number 4, is when you are accessing Google Docs or Microsoft Word online for accessing the features of a document writing software from your browser without specifically installing them, which cloud service model you are using? Options are software as a service, platform as a service, infrastructure as a service, database as a service. Anyone? I'm repeating the question. So whenever you are accessing Google Docs or Microsoft Word online for accessing the features of a document writing software from your browser without specifically installing them, which cloud service model you are using? Options are software as a service, platform as a service, infrastructure as a service, database as a service. Anyone? So the correct option for this is software as a service. This is an example of software as a service, because as you are accessing Word or document processing software as a client through as a service through the client. Next question is, in cloud computing service model, what does XaaS stands for? Options are security as a service, connectivity as a service, network as a service, anything as a service. So what does XaaS stands for? Security as a service, connectivity as a service, network as a service, anything as a service. Anyone? So the correct option for this question is anything as a service. So X in XaaS stands for anything. XaaS is a collective term that refers to the delivery of anything as a service, that is your infrastructure, software and your platform. So it is the collective term which is used for everything or anything as a service. Next question, that is your question number 6, is Microsoft Azure is an example of blank service provider. Options are SDN, second option is cloud computing, third is batch computing, fourth one is operating system. Anyone? Microsoft Azure is an example of blank service provider. Options are SDN, cloud computing, batch computing, operating system. So the correct option for this is cloud computing. So Azure is a cloud service which is provided by your Microsoft. Next question is, no virtualization is used in cloud service provisioning. True or false? I am repeating the question. No virtualization is used in cloud service provisioning. True or false? Anyone? So the correct option for this is false. So basically cloud computing uses the concept of virtualization heavily to provide continuous dynamic on-demand services. So virtualization is the creation of virtual version of something. For example, your server, desktop, storage device or an operating system or network resources. So basically virtualization is a technique which allows to share a single physical instance of a resource or an application among multiple customers and organizations. It does by assigning logical name to the physical storage and providing a pointer to that particular physical resource when demanded. So the creation of a virtual machine over existing operating system and hardware is known as your hardware virtualization. A virtual machine provides an environment that is logically separated from underlying hardware. So this virtualization can be of various types. For example, your hardware virtualization, operating system virtualization, server virtualization, storage virtualization. Now next question is, What does DBaaS stands for in cloud computing service model? Options are disk as a service, database as a service, distribution as a service, data buffering as a service. Anyone? What does DBaaS stands for in cloud computing? Options are disk as a service, database as a service, distribution as a service, data buffering as a service. So the correct option for this question is database as a service. So database as a service is a cloud computing managed service offering that provides access to database without requiring the setup of physical hardware, the installation of software and the need to configure the database. So most database administration and maintenance tasks are handled by service provider, which enables the user to quickly benefit from the database service. So the use of database service is growing as more organizations are shifting from your on-premise database to your cloud databases. So the database as a service vendors include cloud platform providers that sell database software and other database markers that host their software on one or more cloud platforms. So most database as a service environment run on public cloud infrastructure, but some providers will also install their database as a service technology on on-premise data centers and manage them remotely for customers in private cloud or hybrid cloud infrastructures. Next question is, suppose a hospital that deals with sensitive patient data wants to have cloud support for all of its computer, but it wants to set up its own secure cloud infrastructure. This is an example of following model. Options are public cloud, hybrid cloud, private cloud, none of these. Anyone? Okay, I am repeating the question. Suppose a hospital that deals with sensitive patient data wants to have cloud support for all of its computer, but it wants to set up its own secure cloud infrastructure. This is an example of which of the following models? Options are public cloud, hybrid cloud, private cloud, none of these. So the correct option for this is private cloud. So basically in case of your public cloud, what happened is anyone in the network can access the data which is stored over the cloud. So in this case, in this question, it is mentioned that there is sensitive data which is stored over the cloud. So public cloud is not suitable option for this. Then hybrid cloud is the combination of both your public cloud and private cloud. So this is also not a suitable option for this. However, in a private cloud, a particular organization is going to manage the data and all the services which are there in the cloud. And furthermore, there is more security which is provided by your private cloud. So that's why for this, private cloud is a suitable option. Next question is, what does CIA in cloud security stands for? Options are confidentiality, integrity, availability, confidentiality, inheritance, automation, congestion, integrity, authentication, criticality, integrity, accountability. Anyone? What does CIA stands for in cloud security? Options are confidentiality, integrity, availability, Then next is confidentiality, inheritance, automation, then congestion, integrity, authentication. Next is criticality, integrity, accountability. So the correct option for this is confidentiality, integrity, availability. So confidentiality, integrity and availability, which is also known as CIA triad, is a model designed to guide policy for information security within an organization. The model is also sometimes referred to as AIC, which is availability, integrity and confidentiality, to avoid any kind of confusion with your central intelligence agency. Although the elements of the triad are three of the most foundation and crucial cyber security needs, that is your confidentiality, integrity and availability. So in this context, confidentiality is a set of rules that limits the access to the information. Integrity is the assurance that the information is trustworthy and accurate. However, your availability is the guarantee of reliable access to the information by the authorized people. Next question is, in virtualization, a hypervisor is responsible for orchestration between underlying physical hardware and virtual machine being installed. Is this statement true or false? In virtualization, hypervisor is responsible for orchestration between the underlying physical hardware and virtual machines being installed. The correct option for this is true. This statement is true. Basically, the hypervisor provides the necessary orchestration between the virtual machines and host computer. Orchestration is the automated configuration, management and coordination of computer systems, applications and services. Next question is, for a secure cloud deployment, which among the following are needed to be considered? Options are network level security, host level security, application level security, all of these. Anyone? For a secure cloud deployment, which among the following are needed to be considered? Options are network level security, host level security, application level security. So the correct option is all of these, because for your secure cloud deployment, we need all these three, that is your network level security, host level security and application level security. Next question is, cloud SIEM is a type of, options are cloud network, cloud simulator, cloud enhancement, cloud model. Anyone? I'm repeating the question. Cloud SIEM is a type of cloud network, cloud simulator, cloud enhancement, cloud model. So the correct option for this is cloud simulator. So basically, this cloud SIEM is an open source framework which is used to simulate cloud computing infrastructure and services. It is developed by Clouds Lab organization and is written entirely in Java. It is used for modeling and simulating a cloud computing environment as a means for evaluating a hypothesis prior to software development in order to reproduce tests and results. For example, if you were to deploy an application or a website on the cloud and wanted to test the services and load that your product can handle, and also tune its performance to overcome the bottlenecks before risking the deployment, then such evaluation could be performed by simply coding a simulation of that environment with the help of cloud sim package without any cost. So basically, if you want to test whether your product is able to handle a particular load, or if you want to check whether the product which you have developed is reliable, then you can use cloud simulator. You can simulate your product over cloud simulator and check whether it is able to or not. Next question is, before cloud computing provisioning, the client is provided with the details of various warranties in which of the following document? Options are service level authentication, service level agreement, software level agreement, software level authentication.
Excuse me, ma'am, could you share your
Okay,
screen,
wait.
please? Thank you, ma'am.
Now is it visible? Okay. Okay, so
Yes,
I'm
ma'am.
repeating the
Thank you.
question. So whenever such kinds of things happen, please unmute yourself and tell, because it is difficult for me to check your messages. So yeah, question is, before cloud computing provisioning, the client is provided with the details of various warranties in which of the following document? Options are service level authentication, service level agreement, software level agreement, software level authentication. Anyone? So correct option for this is service level agreement. So basically, this service level agreement is the bond for performance negotiated between the cloud service provider and the client. So in cloud computing, all the service level agreements were negotiated between the client and the service consumer. So it can be at service level agreements are also defined at different levels, which can be our customer based service level agreement, service based service level agreement, or multi level service level agreement. Next question is, Amazon Web Services is an example of, options are open source cloud, deployment cloud, commercial cloud, not a cloud platform. Anyone? Amazon Web Services is an example of open source cloud, deployment cloud, commercial cloud. It is not a cloud platform. D. AWS is not a cloud platform. So it is a commercial cloud. Next question is, the process of abstracting physical network hardware and resources from the network services and use cases are known as, options are network splitting, network virtualization, network scaling, none of these. Anyone? The process of abstracting the physical network hardware and resources from the network services and use cases are known as network splitting, network virtualization, network scaling. None of these. Anyone? No? Okay. So correct option is network virtualization. So basically network virtualization is a process of logically grouping the physical networks and making them operate as a single or multiple independent networks, which are also called as your virtual networks. So it is the process by which various network services are abstracted from their underlying physical hardware for smooth management of your network. Next question is, ODIN is one of the proposed solution towards software defined WSN and mobility management. As per the architecture of ODIN, which component of ODIN is placed on the top of the controller? Options are ODIN master, ODIN agent, both ODIN master and agent, neither ODIN master and agent. Anyone? ODIN is one of, I'm repeating the question, ODIN is one of the proposed solution towards software defined WSN and mobility management. As per the architecture of ODIN, which of the component of ODIN is placed on the top of the controller? Options are ODIN master, ODIN agent, both ODIN master and agent, neither ODIN master and agent. Correct option for this is ODIN master. So basically in case of your ODIN, there are two components. One is your ODIN agent and other one is your ODIN master. So basically this ODIN agent is placed at the physical layer, that where the hardware is there near to the access points, and your ODIN master is placed over your controller, and the communication between your access points or the hardware with your controller take place with the help of your ODIN agent and ODIN master. So basically the hardware communicate with your ODIN agent, then ODIN agent further communicate with your ODIN master, and this ODIN master then further communicate with your ODIN controller. So this ODIN master is placed over your over the top of the controller, so that the communication between your hardware and controller can take place. Next question is, that is question number 18, is shared pool of resources with easy configurability are important aspects of cloud computing. Options are true or false. This question is very easy. Shared pool of resources with easy configurability are important aspects of cloud computing. Is this statement true or false? Anyone? So the correct option for this is true. Basically, in case of your cloud computing, there is a shared pool of resources from which the end user can access the resources on the basis of their demand, and there is easy configurability of these resources. So this statement is true. Next question is, in cloud computing, the user have specific knowledge about the exact physical location of computing hardware with respect to cloud services. Options are true or false. So do the end users have the knowledge of location of your computing hardware resources in case of cloud computing? This is the question. True. So okay, so you are saying that in case of cloud computing, end users have the knowledge of the exact location of physical resources. Are you replying for this question or the previous one? Okay, false. Yeah.
False is for present question, ma'am.
Okay,
False
okay.
is for present question,
Yeah,
ma'am.
so this is correct. So this statement is false. Basically, in case of your cloud computing, the end user does not have the knowledge of exact location of the physical resources. Basically, end user feels that there is one centralized pool of resources where there is infinite number of resources, but in actual these resources are distributed globally and the end user does not know about their locations. So this statement is false. Next question is, suppose there are two organizations A and B, both of which provide cloud services. Any user can access the cloud of A free of cost, whereas only employees of organization B can access the cloud of B. Also, organization B has set up its cloud for only its own need. With respect to the type of cloud infrastructure which is provided by A and B, which of the following is true? So option A is private cloud and B is public cloud. Option B is A is public cloud and B is private cloud. Option C is A is public cloud and B is public cloud. Option D, both A and B are private cloud. Anyone?
A is public cloud and
Right.
B is private
Yeah,
cloud, ma'am.
right. So basically
B1.
here in the question it is given that for A anyone can access, whereas in case of B only the employees of B can access, and the cloud which is managed by organization is for B. So basically A is public cloud and B is private cloud. So option B is correct. Next question is, which among the following can be considered as a potential service model for cloud computing? Options are software as a service, database as a service, platform as a service, all of these. Anyone? I'm repeating the question. Which of the following can be considered as potential service model for cloud computing? Options are software as a service, database as a service, platform as a service, all of these.
All of us, all of these.
Yeah,
All of
right.
us, ma'am.
All of these
All
is
of
the
these.
correct option. Next question is, which of the following component can be considered as optional for a sensor node? Okay. Options are sensing unit, transceiver, location finding unit, none of these. So this doesn't belong to the topic of this week. This question is related to previous topic, previous week's topic. So which of the following can be considered as optional for sensor node? Sensing unit, transceiver, location finding unit, none of the above.
P1 C1, ma'am.
Which?
C1, ma'am.
C, ma'am.
C,
Location
location
finding
C,
unit.
finding
C,
unit.
ma'am.
Right,
Location
because
finding
in case
unit.
of your sensor node, sensing unit is required in order to collect the data. Then transceiver is also required in order to transmit the data. However, location finding in unit is not necessary. So this is the optional unit. So C is the correct option. Next question is, you have bought a spreadsheet processing software in the form of CD-ROM which you would need to install yourself on your computer to run and then manage. Is it an example of software as a service in cloud computing? Options are yes or no.
No, ma'am.
No.
No,
Okay,
ma'am.
anyone else? Okay. So this statement is so this is not an example of software as a service because you are not utilizing this spreadsheet processing software as a service. You are installing that in your system and then using it and also managing it yourself. So it is not an example of software as a service. It will be an example of software as a service if you are not installing it in on your computer and you are using as for example excel sheet is there, google excel sheet is there. If you are using that spreadsheet in order to maintain your data, then that will be the example of software as a service. However, in this case you are installing that in your computer and managing yourself, so it will not be an example of your software as a service. Next question is, suppose two person A and B both wish to access a particular software as a service feature from the cloud service provider through their respective personal computers. Both of them log into the cloud at the same time. Then which among the following is true? Options are, neither A nor B will be able to access the services. A will be able to access the service but not B. B will be able to access the services but not A. Both A and B will be able to access the services.
D1, ma'am. Both A and B will be
D1,
access
ma'am.
the service.
Both A and B will
Okay.
be access the
Anyone
services.
else? Anyone else? Yeah. So correct option is D, that both A and B will be able to access the services. Next question is, along with accounting, which among the following is an essential component of cloud service management? Options are virtualization, billing, deployment, none of these. Along with accounting, which among the following is an essential component of cloud service management?
Virtualization, ma'am.
Virtualization, ma'am.
Okay, anyone else? Cloud service management. Anyone else? answer for this? Yeah. So the correct option for this will be billing, because for cloud service management, along with accounting, billing is required, because accounting means you are managing that how much resources are used for what amount of time. So along with that, billing is also an important essential component for your cloud service management. Yes. Okay, so this is one more question, that which among the following security paradigm is concerned with security the in transit data between the user and the cloud through the internet. So options are network level security, host level security, application level security, none of these. So the correct option for this is network level security. Next question is, cloud security ensures that blank users can access their data after proper blank. Choose which among the following should be correct order of words to be filled in the blanks. Options are legitimate, second is authentication, B is illegitimate authentication, malicious inaction, malicious attack. Anyone? Cloud security ensures that blank users can access their data after proper blank. Options are legitimate authentication, illegitimate authentication, malicious inaction, malicious attack. Very easy question.
A1, ma'am.
Right.
A1, ma'am.
Basically, only the legitimate users can access the data with proper authentication. So A is the correct option.
Yes, ma'am.
Now next question is, which among the following should be protected with proper access control in cloud computing? Options are database access, server access, virtual resource access, all of these. Anyone? I'm repeating the question. Which among the following should be protected with proper access control in cloud computing? Options are database access, server access, virtual resource access, all of these. Anyone? No? So the correct option for this is all of these. So so database, server, virtual resource access, all those should be protected with proper access control. Next question is, before launching your cloud service as a product to customer, it is always a good idea to test your cloud application on a cloud simulator first in the pre-deployment phase. Is this statement true or false?
True, ma'am.
True. Okay.
True, ma'am.
Anyone else who wants to reply? Yeah, so this statement is true. So before launching your cloud service as a product to customer, it is always a good idea to test it because whether your product is able to handle the particular load or not, whether it is working properly or not. So it is a good idea to test that application on a cloud simulator. Next is, with respect to virtualization in cloud computing, which among the following can be considered as suitable virtualization paradigm? Options are storage virtualization, hardware virtualization, application virtualization, all of these. Anyone?
All of these, ma'am.
All of these, ma'am.
Okay. Anyone else? So correct option is all of these. Next question is, along with accounting,
Hardware virtualization, ma'am.
what?
Hardware virtualization,
No,
ma'am.
all of these is the correct option. Next question is, along the so yeah, this question is already done. Yeah. So along with accounting, which one of the following is essential component for cloud service management? So billing is the correct option. I have already discussed this. So yeah, so this is the again same question. Okay. So these were the questions of week 8. I have already shared the link with you. I have uploaded the I'll again share the link. So I have shared the link with you, the drive link where I have uploaded the PDF. You can check all the PDFs I have uploaded from week 1 to week 8. Okay, so thank you. Now we will meet on next Friday.